Hello friends, welcome to my channel Aug CS revision notes. So friends, we are solving UGC NET 2024 computer science paper. So we have completed almost all the units. So today we will see DBMS, and if you need a link for the previous videos, please see the description. So if you need notes, please follow my channel. So the question number 74. Question number 74. Fifth normal form is concerned with joint dependency, domain key, multi-value dependency, or functional dependency. So first normal form is the default one, and here the form will be that all values will be atomic. So it is the first normal form. Second normal form, the condition is there should be no partial dependency. Third normal form condition is there will be no transitive dependency. BCNF, this condition is it is a relation with two attributes. Then fourth normal form, the condition will be there should be no multi-value dependency. And fifth normal form, there is no non-loss decomposed or joint normal form. It's always called joint normal form or joint dependency. Hence the correct answer to this question is option number 1, that is joint dependency. So question number 75. So how does a relation database ensure data integrity? So options are by encrypting all data stored, by enforcing rules defined in the schema, by compressing data for efficient storage, or by allowing unrestricted access to all users. So the correct answer is by enforcing rules defined in the schema. So in that way, the relation database will ensure data integrity. The correct option is option number 2. Question number 76. What is SQL primarily used for in the context of relational databases? 1. To design user interfaces. 2. To create and manipulate databases. 3. To display data on web pages. 4. To format printed reports. So SQL is primarily used to create and manipulate databases. Hence, correct answer is to this question number 76 is option number 2. Question number 77. Which of the following best describes the structure of a relational database? So data is organized in tables with rows and columns. Data organized into files and folders. Data organized into a hierarchical tree structure, or data organized into a network of interconnected nodes. So data organized into tables with rows and columns. Correct answer is option number 1. Question number 78. Consider a schema R, PQRS, and the following functional dependencies, that is P tends to Q, Q tends to R tends to S, and S tends to Q. Then decomposition of R1 as P and Q, and R2 as Q and R, and R3 as Q and S is what? So they are given 4 options. Whether it's, so here we have a relation R, PQRS, and then we have R1 PQ and R2 QR and R3 QS. So you see that the condition for lossless join is it should have a common attribute. So here Q is the common attribute, and next you should check if Q is a candidate key for any relation. So let us check for R1. R1 is P and Q. So take the closure of Q. So closure of Q is Q. The closure of P, it is P and Q because P tends to Q. Next, R2 relation. Next, in R2 relation, R2 has Q and R. So Q closure is Q, and then Q tends to R. So Q has closure has Q and R closure has only R. In R3 you have Q and S. So Q closure is Q, and S closure is S, and Q as S tends to Q. Q is candidate key for relation R2 because Q derives all the attributes in R2. Hence, you can see that it is a lossless dependency preserving join. So correct answer is option number 1. So the correct option is option number 1, that is dependency preserving and lossless join. Next, question number 79. Consider a relation schema R equal to U, V, W, X, Y, and Z on which the following functional dependencies hold. So U tends to V, W tends to X, Y tends to W, and X tends to U. From these, you have to find out the candidate keys for R. So let us see how to solve this problem. So R is a relation with U, V, W, X, Y, and Z, and given the dependencies. So one trick to find out the candidate key is to check the right hand side. So right hand side you have V, X, W, and U. So you have U, V, W, X. So you don't have Y and Z. So on the right hand side you don't have Y and Z. So it is obvious that Y and Z should be contained in the candidate key. So let us check the options. You find that in the options you have, if you have YZ, then it is a correct answer. From the option you have Y and Z is not found here, so this is not the correct answer. So YZ not found here, but you have Y and Z here. Okay. From here you see here YZ is there, YZ and W is it. Here YZ, here YZ and YZ. So can put option 4 as such. Okay. So option number 4 is the correct answer because you have all in all the three you have YZ as the candidate key. Okay. So how can you prove this? So if we take the last option VW is it or XY is it, from these you find that VW is it, if you take the closure, will not contain Y. If fourth option UY is it, so if you take the closure also you'll get the all the attributes UY is it, VWX, and VY is it also you get VY Z W X and U. We derive all the attributes. Hence, the correct option is option number 4. So XYZ, UYZ, and VYZ are the candidate keys. Hence, the correct option to question number 79 is option number 4, that is UYZ, VYZ, and XYZ. Next, question number 81. Again, you have a schema R, A, B, C, D, E, F, G, H, and each field in R contains only atomic values. So F is equal to, they given the functional dependencies, and then so that F is exactly, F plus is exactly the set of FDs that holds R. The relation, now they are asking to what sort of relation it is. That is, the relation R is 1NF or 2NF or 3NF or BCNF. So that's what the options are. So let us see how to solve this problem. So here you have given the functional dependencies. See, as one of the functional dependencies derives T. So from the, you have check the right hand side, the attributes in right hand side, and see if you can get the candidate key. So you have G, you have B, C, C, F, H, A, E, and G. That is, you have A, B, C, E, F, G, H. So without D you have all the attributes in the right, so it means that D is surely should be in the candidate key. So okay, hence can, what are the possible candidate keys can occur? So it can be A, D, B, D, C, D, E, D, F, G, F, D, G, D, and H, D. So let us see the closure for each and one every one. Okay, so if you take AD closure, you get all the attributes. You can derive C get all the attributes because AD, then A derives BC, so B derives CFH, and then CH derives G, and then F derives EG. So you can derive all the attributes in AD. Similarly for BD, see, you get all the attributes A, B, C, D, E, F, G, and H. If you take CD, you can't derive more than that because D has no derivations, and C also does not stand alone. So CD has no, closure of CD does not derive all the attributes. So ED also derives all the attributes because I have ED, then E derives A, then A derives BC, then B derives CFG. So from that you can derive all the attributes. Similarly, FD also you have can derive all the attributes because F derives EG, E derives A, and A derives BC, and you get A all the attributes. GD closure also you cannot derive all the attributes. It's only GD, and HD also you cannot derive all the attributes. It's only HD. So possible, what are the candidate keys possible? The candidate keys are AD, BD, ED, and FD. So from these you have to check the normal form. So let us see the normal form. So first asking about the, when you check the normal form, first you go start from the BCNF. So when you check the normal form, you have to start from the BCNF. So BCNF, what is the condition? So X derives Y means X should be the super key. So here for each of the functional dependencies, if it satisfies this condition, then it will be in the BCNF. So first functional dependency, first we'll take CH gives G. But you find that CH is not a super key because it's not part of the candidate key. So it is either in a candidate key or it is not a more than candidate key. So it's not a super key. Hence, it is not in a BCNF. Next is find the 3NF. So 3NF, what is the condition? So X derives Y means X can be the super key or Y can be the prime attribute. So this is the condition. So either X can be a super key or Y is the prime attribute. This is the condition. So here again you take the first functional dependency, that is CH gives G. Here we found that CH is not the super key. So let us see if G is a prime attribute. So if G is, we find that G is not prime attribute because we find the candidate keys as AD, BD, ED, and FD. So G is not in any one of these. So it is not a prime attribute as well. Hence, it's not in 3NF. So let's go to 2NF. So 2NF means there should not be any partial dependency. So what is partial dependency? If the candidate key, part of candidate B derives a non-prime attribute, then it say that this has a partial dependency. So let us take the first functional dependency, that CH gives G. So here you have no partial dependency because CH is not part of the primary key. It's not part of candidate key, and or G is not the prime attribute. So first is not there. So next functional dependency, take A gives BC. Here A tends to BC. Here B A is a part of candidate key. Okay, but here B is a prime attribute, but C is not a prime attribute. So here also partial dependency exists because part of candidate key derives also a non-prime attribute. So here partial dependency exists. Even if you take B gives CFG also, here partial dependency exists because C and H are not part of, it is not prime attributes. F is a prime attribute because FD is a candidate key, but C and H are not prime attributes. Hence you see that as part of candidate key derives non-prime attributes. Hence a partial dependency exists. So it is not in 2NF either. So therefore the relation is in 1NF only. So the correct option is option number 1. And the correct option to question number 21 is the first one, that is in 1NF but not in 2NF. Next question, question number 82. So it's regarding transactions and then whether it is conflict serializable or not. So friends, you remember in our channel we already discussed this question as a separate video. I have done a separate video, detailed video for the same question a few months back. So you can have a look at it I shall give the link in the description. Here we have solved this problem in a detailed manner. So I request you to please follow the link. Next, question number 91. Arrange the following phases of database design in the correct order. So physical design, conceptual design, logical design, and requirement analysis. So when you do a database design, it should be the correct order. So database design refers to requirement analysis. Then we do the conceptual design, then the logical design, and then finally the physical design. So correct option is option number 3. So it is DBCNA. So question number 91, correct option is option number 3, which is DBCNA. So friends, we have completed all the problems from DBMS. Only question number 18 is left, which can be done as a separate video. So friends, we have watched the video till this end. So I'll give you a note on how to access the notes. So here you can contact me by my email address, that is itsmeeraji10@gmail.com, or you can WhatsApp me at 98406250046. Raji CS Revision and Notes channel provides notes which has question and answers in PDFs and paper 1 notes as well as paper 2 notes in PDF form. So please write to me so that I can provide you the notes. Like, share and subscribe my channel Raji CS Revision and Notes. Thank you.